Well, hi there. Hello. I heard you want to do some chemistry. You don't want to do chemistry. You're here because you need extra help. So probably you don't want to do this, but you find it necessary or whatever, right? So, right, we're converting between amounts that we measure, things like volumes and masses and that kind of thing, to things that we count, moles and molecules. Moles is a bunch count at once. Molecules is an individual kind of count, right? We're typically going to deal with moles. Not going to deal with molecules very often, but I think it's good to see that, right? So let's say you go and buy some fertilizer, right? A common fertilizer for plants would be something like potassium nitrate. That's also used in gunpowder and in chemistry class, right? It's a common little chemical. So if I'm going to want to convert that, then I need to know what that conversion factor is. And that conversion factor is called, hint, it rhymes with polar bass. What's the conversion factor we use to go between moles and mass? It's called molar mass, right? Molar mass goes between grams and moles. So I'm going to use my handy dandy periodic table for that. So if I have KNO3, I need the molar mass of potassium, right? We're going to do a little side problem here. And I can find those molar masses, remember, right there underneath the element on our periodic chart. So potassium is 39.10. Go ahead and write those zeros in so that we know that they're measured. And then nitrogen is 14.01 and oxygen is 16.00. Again, writing those zeros in so that we know that we didn't round those off, right? We write the zero so we know that they're not rounded. But those are the 3 molar masses, but you see it? There's a 3 there. What do we got to do with that? Right? There's 3 of those, so we multiply that by 3. So I am too lazy to do this by hand, even though this one wouldn't really be very hard. So 39.1 plus 14.01. Remember, these are plus in between. Don't times those in between. Plus 16 times 3. Right? So I just do that all on my calculator, and my calculator tells me that's a lot of ones. It's 101.11 grams per mole for potassium nitrate. That means 101.11 grams equals 1 mole. Right? That's what that would be, right? So a mole is the same count all the time, but it weighs different amounts. Like a dozen is always 12, but a dozen cars weighs different than a dozen Cokes and a dozen golf balls, right? Because each one is different mass. So that is the conversion factor that I'm going to want to use is this 101.11 grams per mole. So if we do this first one, now that's grams and that's kilograms. Well, I can change kilograms just by moving the decimal point like we did earlier this year. And it goes kilo, hecta, deca, base, right? Remember that's on the back of your periodic chart if you forget. Or you can just remember that kilo means 1,000. So 20 kilograms is 20,000 grams. Why can I not remember which way a comma goes? That looks wrong. Does a comma go this way? How can I not remember a comma right now? Oh, comma goes the other way. You're like, what's wrong with my teacher? Right? So 20,000 grams of KNO3. So if I want to convert that to moles, I'm going to use this 101.11 grams per mole. I want the units to cancel. So we'll do 101.11 grams of potassium nitrate for every 1 mole of potassium nitrate. Now this grams per mole, it's just like miles per hour. If you're driving 60 miles per hour, that's 60 miles per 1 hour, right? So grams per mole is always going to be opposite 1 mole. And then the number will go with grams, just like a speed, right? The number goes with miles and 1 goes with hours. Well, the number goes with grams and 1 goes with moles. If I had moles here instead, I would have flipped this over. I still would have had the number with grams and the 1 with moles, right? So 20,000 divided by 101.11 is 190. Well, we've got 2 digits here, really. So let's just go with 197.88. So we'll round that to 200 moles of KNO3. You can use a line over that to show where your measured value is, right? Because you can't tell the difference between rounding and not rounding. But that way we can show 2, right? If you did it to 198, that'd be fine too, right? So then they also ask us about molecules. Well, that molecules, remember, that was on the packet there, and it tells us that 1 mole is 6.02 times 10 to the 23rd molecules. That's on the back of your periodic chart. that is when I run into people and they're like, oh, you teach chemistry, 6.02 times 10 to the 23rd. Like that's the only thing that matters in chemistry. It doesn't matter that much, right? This is not like the end all be all, but people get very excited about how many particles are in a mole. If you want to memorize it, feel free. We're not going to do it very often, but I think it's okay to do that, right? So if I've got 200 moles, I'm going to use the unrounded one for the answer or for the calculations, right? So this many moles of potassium nitrate. Well, for every 1 mole, it's 6.02 times 10 to the 23rd molecules. Really, molecules is typically a thing we talk about with covalent things, and this is ionic, but it's still an individual particle kind of. So 6.02, and remember that's the EE button, right? So second, and then usually above the 7. 6.02, EE23, and so that gives me 1.2 times 10 to the 26th molecules. So that would be 1.2 and then 25 zeros after it. So that's in the heptillions, right? That would be in the heptillions, like, right? Millions, billions, trillions, quadrillions, pentillions, hexillions, heptillions, right? That's in the heptillions. It's a lot.